Hello guys, the last day I gave ye materials technology wood ordinary level short question set section A, sorry, which is the short question section of the exam. And on it asks you to answer any 16 lines, asked you to answer all or as many as you could. And now I just want to go through them just to make sure you know what you're doing and to make sure that you all gone on okay and to clear up anything that you may have gotten wrong or maybe you just didn't know, and also maybe to add some things to it. So my big deal here will be to add information to this and make it into more of a theory class than just a short question exam paper. Now, you will know, or at least I hope you know at this stage, that not only will there be short questions during exam, but there will be long questions as well. But at the moment, while we are at home and trying to learn and so on, I'm going to be working through a lot of, well, at the moment, the ordinary level sets of short questions. And from there, I will work to the higher level short questions because they get a lot of theory covered very, very quickly. All right, so first thing, section 8 is worth 40 marks. You normally would answer 16, but I want you to answer all. From the list given, identify the nails shown. Now, some of you might know this, some of you might not. So what I did with it, or what I thought about in my head when I was answering this, is I said to myself, right, how would I figure this out? And really, apart from checking your book, you would need to know off by heart what each one of those items is. Now, A is a staple and B is an upholstery nail, okay? A round wire nail is literally a round. Okay, upholstery nail. Okay. Question 2 then. You're used to seeing this question. I've given it to you a few times, I'd say, in your exam, or at least versions of it. At ordinary level, the first thing I'm supposed to note is that there is a choice as to whether you want to answer, which one you want to answer. I answered both because I think it's important. So name the two labeled A in the diagram. It is a try square, T or Y. I've often said that to you, T or Y, to try for square, to check for square, and it's to check the angles are square or 90 degrees in a project, or to mark lines at 90 degrees on a project. So in terms of getting full marks there, if this was your exam, what I'd be interested in seeing is that in terms of keywords, that you put the keyword square or 90 degrees in there somewhere, or even if you highlighted maybe that the angle in here on a tri-square is 90 degrees, that would help as well. Okay. The next one then is most of you would have wrote chisel, but it is a firmer chisel, which is slightly different. A firmer chisel, if I just point it out to you here, has a straight edge on the side. So it's somewhere in between a mortise chisel and a bevel-edged chisel. There is no bevel edge on this chisel here. It has a straight side, so therefore it is a firmer chisel. So if you didn't get that right, fix it. F-I-R-M-E-R chisel. What is this used for? It's used for trenching or making chamfers, or it can be used for what you call it, chopping out, or for shaping. Any of those kind of traditional stuff, any chisel would really be used for. Next one, then you were asked to name the green feature shown at A. A lot of you would have written not, and that would have been fine. But as a full answer, or if you're thinking of, I'll be a higher level candidate, dead knot is what I would put down as the correct answer. Why is it a dead knot? Because of that black section of the knot. Okay, so it's a dead knot. So a black knot or a black ring indicates a dead knot. Oh, the rest is messy. Okay, so that black ring indicates that. If there was no black ring there and there was just a gathering of green, I'd say that was a live knot. So live knot looks kind of the same color as the timber itself. This guy then, you would have come across it in our fixtures and fittings chapter, although we haven't looked at it too often. What is it actually called? It's called a ball catch, okay? And what actually happens is that in use, this little ball section here pops in and pops out. So when you try and close a door or you push the door closed on a cabinet or a press or something like that, the ball just pushes in enough to allow you to close the door and then pops out once the door is closed. And really, its only job and its only thing is to keep a door closed. So in a cupboard or a press where a lock isn't needed, you'd have this ball catch. Okay. Next one then. State from which trees in the list these seeds come. So first one comes from an oak tree. They are, I hope, obviously enough, acorns. Okay. And then the little helicopter fruit come from the sycamore tree. Now, just if you didn't know them off by heart, at least you have a choice here. We should know, or I hope you know, well, holly has berries. Oak, yes, it has acorns. We've already used that. Pine is a softwood. So if it's a softwood, it would have cones. None of them are cones. Okay, birch it could be, sycamore could be, or ash it could be. And then the one from that list is the sycamore. So I was minimizing the list down as much as I could. Okay, so sycamore. Name the power tool shown in the diagram. That's the sander, or some of you might have written it's a mouse sander because of the shape. It's more of a DIY tool than anything. We wouldn't have that kind of sander in the woodwork room. We'd have bigger ones. List 2 safety precautions that should be observed when using portable electric power tools. Now, I want to draw your attention to the fact here that it's safety precautions. It's not a safety rule necessarily. Precautions and rules are similar but different. And this is about the using of a portable electric tool. So it's not just, oh, tell the teacher if something is broken, even though that is a safety tool or safety not a rule or tool, a safety, what would you call it? A piece of advice, really. With this one, it's if I'm using a portable power tool, so such as a drill or maybe a jigsaw, what are the safety rules associated with that, or the precautions? What should I be careful of? Because that's literally what a precaution is. So, and write it into yours as well, because unless you write it, you won't remember it. What should, oops, I be careful of? Okay, and in this case, it's number 1. What precautions should I take? I should wear protective eye equipment. So that is one precaution. Another one, because I wrote down 3, is you should ensure that the cable is in good condition. So if you're using a cable or a tool that has a cable attached to it, that it's not frayed in any way or damaged. And the third one I put down, because no harm putting down 3, I said to keep the cable away from the work. So imagine you have a jigsaw and you're cutting away. The last thing you want to do is cut through that cable. Okay, so that was question 7. Next one. Now, this is interesting. I don't think I've ever kind of mentioned this in class, or at least if I have, it's only been in passing. So I'd love to see actually what you wrote here. I have some of them looked at already, but I haven't seen anything terribly interesting yet, or anyone that seems to understand or know what is happening. What they're asking you is they're saying, right, how can the end grain of a wide board be planed without, okay, the edges being chipped off? So they're showing you a board there where the edges are chipped, and they're saying, right, if you plane across the end grain of any piece of timber, right, just this piece of timber in particular, of any piece of timber, the grain, the edges will start to chip off. You've done it with your chisel. It's the same sort of effect. So in other words, if I go this way with the chisel or the plane, I will naturally break the grain of the timber and I knock the chips off, right? So that's what's happening. So how do I counteract that? And counteract is the right word for it, because it's how do I go against it? And what you should do is you should actually plane from the outside inwards. So I'd start at this corner and I'd plane inwards. I'd go over to this corner and I would plane inwards as well. Okay, and I'd meet in the middle. And if all fails, I could also use a shooting board, or I could attach a piece of material. I could put in a little waste piece of material in here that stops the grain breaking under these conditions, or at least it helps stop it. So I could stop it coming off like that. Now, with this one, it's a very good idea to put in those arrows, okay, because it helps explain it quite simply and easily to the examiner as well. Okay, diagram shows a section of the trunk of a tree. What is the name of the darker colored wood? And yes, this section in here would normally be quite dark in comparison to the outside section of the tree. And the reason for that being is this would be the older section, and the tree itself at this point in the yellow section, or the lighter section, is still growing, whereas the inside section is just that bit older and it's no longer growing. It is no longer, how would I put it? It's dead effectively. It's, hang on now. I'm trying to talk and draw at the same time, so I need to stop this now a minute. Shall I just try this? I'm trying to make it pretty. There we go, there's the bark. Okay, and what has happened is the tree has started to grow from the inside. You should remember that that line down there through the trunk of the tree, if you remember back to first year, last year, not, or even maybe not that long ago, I have often told you that that is the pith, which is the dead center of the tree. And around the pith, then the tree begins to grow and layers get added over time, and it's the outside layers that are still alive. So the name of it is the heartwood, and just while we're at it, the sapwood is the name of the yellow section. It contains the sap. It is the alive section. There it is. So this part here is the sapwood, and this is the heartwood. Okay, number 10 then. Show by means of a tick which type of seasoning is most suitable for timber used in the following locations. So we have two types of seasoning here. We have air seasoning, which generally will get timber down to a moisture content of about 18, maybe to 20%, possibly more. Whereas kiln seasoning will bring it down to 7%, 8 and 9%, in around there. Okay, so they're saying, right, if I season timber and it's very, very dry, where should I be using it? If I season timber and it is only kind of dry to the outside air, where should I be putting it? So basically, fencing posts to be used outside, they would be air seasoned. Floorboards are inside, kiln seasoned. Shelving, kiln seasoned as well, because they're inside. Dog kennel stays outside for the most part, for most people, so it's an air seasoned thing. And a kitchen table would be used inside, kiln seasoning. So basically these, if you think about it as being air seasoning is for something that goes outside, and kiln seasoning is for something that is inside, indoors. Okay. Coping saw. The blade of a coping saw is held in place with which of the following forces? So I've already put in the answer. The answer is tension. But why is the answer tension? Compression is a push force, right? So if I was to try and draw a little doodle to show how compression happens, it is basically two forces being pushed together, okay? Tension then is the exact opposite of that. It is two forces pulling against each other. So the forces are going like that. Torque then is a twist force, so effectively it's a force that is acting on twist. Now, first of all, if this blade over here was under torque, well, the blade would be twisted. If the blade was twisted, what happens to a twisted blade? I'm sure you know at this stage. It ends up breaking. Okay, so that's that one. The compression one, the blade, if it was being compressed, our blade would be being pushed in together like that. But if I push my blade in together like that, what would actually happen is the blade would curve and it would break again. So it's not that. So we're left with tension, because when you twist the handle, right? So when you twist that handle down there, it causes the frame to push outwards. So the frame pushes out in this direction from this side, and it does the same thing from the other side in the opposite direction. And there is our tension force, very important, and we see it in here. So the blade is under tension, and it is the tension then that causes the blade to be stiff so that you can cut with it. Okay, tension. All right, next one. Why are the ends of planks painted before seasoning? And I have often indicated this to you on timber that I'm having to do. What does it do? It slows down the drying of the end grain, which helps prevent splits. Okay, so sometimes, not sometimes, a lot of times when you have timber, so we'll say here's a piece of timber. Okay, there's the end grain. So you're going seasoning that timber. And what happens is that timber has end grain, okay, that looks something like this down there at the end of the timber, whereas down along here, we're kind of looking at the side of those grains, okay? And what actually happens is as you are seasoning, drying the timber, the first place the water starts to escape from is this section here, this end section. And the reason it tries to escape is because you have literally cut open grain, the cells. That's what you've done when you cut that tree down. You've cut open the cells. So these ones are particularly open, right? Because that's what you've done. And they try to escape from there first. And if they go too fast, what happens is the tree splits down the middle there. Okay. And because it splits down the middle, we end up with timber that has end splits on it. And if this was the woodwork room I was in this minute, you'd be handing me back the timber and telling me missed that split. Okay, so what we have to do is we put a sealer. The paint acts as a sealer and it stops that end splitting. Okay, so it helps prevent those splits. When turning a large bowl of wood in the lathe, should the lathe speed be set at fast or should it be set at slow? Well, it should be set at slow. But why is that? Well, there's a few reasons. One is the finish will be better, right? And that's just a basic one. So a slower speed, better finish. Just like on the scroll saw, a slower speed on the scroll saw will also give you a better cut, smoother finish. Another one then, it is safer. Slow is safer. But that's not the main reason, to be honest. The main reason though, and this is more something you should learn off, the larger the stock, the slower the speed should be. Okay, so that's important. The larger the stock, the slower the speed should be. And a bowl, if it's been turned, is quite large. It's certainly a hell of a lot larger than the spindle turning you did there before Christmas. Different kettle of fish really altogether. Okay, so the larger the stock, the slower the speed. That's just something you should know. Okay. Question 14. Name one function of the roots of a tree. Well, it anchors the tree, right? But is there any more I could have put in there? I could have put in that it sucks up the water and the minerals and the food for the tree. It sucks up the water, minerals and food for the tree. We already said the anchoring. Oh yes, it would store food for the tree as well. Okay, so we'll put that one there. Now, one that you'll have seen in the metalwork room. We won in the woodwork room as well. You don't see it quite as often, mind you. The diagram shows an electric strip heater. What is this heater used for? So this is used to heat thermoplastics along a bend line, so perspex, right? Like what is a thermoplastic? Thermoplastic such as perspex or acrylic, okay? And what you would do is you would put your piece of perspex or acrylic across the strip heater, and you'd have a line drawn in the middle of the plastic, and you'd heat it up so that when you take it off the strip heater, you can bend it along that line that you had marked on it. Okay, and that's literally what it does. It heats it up very at an exact point on the plastic to allow you to bend it. Okay, so that's 15. 16 then, and I drew a diagram of this. I went ahead and drew it because I knew it would take me a while now if I was to draw it now, but I'll explain it. The diagram shows a thumb gauge, and they say what's a thumb gauge for? Well, first of all, the reason it's called a thumb gauge is it's quite small, so it's kind of thumb sized. It's a small little piece of material. I think I showed you one there during the year. Usually it's set at maybe 5 millimeters or 10 millimeters, something like that. And by that, what I mean is that the measurement in there to there, actually I did a color here now. The measurement from there to there will be 5 millimeters or 10 millimeters or something similar. Okay, and then what you actually do with it then is, here's my piece of timber down here. You would put the thumb gauge up against the edge of the timber. So in other words, the thumb gauge will be pushed in this direction. Okay, and it will be pushed up against the corner, and you'd run your pencil just along the edge of the timber. And what it does is it draws you a line parallel to the edge of the timber, something similar to the marking gauge, only the marking gauge leaves behind an actual cut. This just puts in a pencil line. And what is it for then? Well, that is used to make chamfers. And just to remind you, I suppose, and I probably should have drawn it there. Well, what is a chamfer? A chamfer is a piece of timber or a corner of something where we take away a 45-degree angle. So it goes from being what you see over there to what you are seeing here in terms of the finished item. So that is a chamfer, 45-degree cut. So that's what the thumb gauge is for, marking them out. All right, 17 was complete the diagram of the cross halving joint shown. So I went in and I added shading, I added grain, but more importantly, I added lines to complete, and I think there was only 3 lines really required to complete the sketch of that joint. But just so because you know this anyway, but just to show I know it to the examiner, I also added in those blue arrows to indicate how the joint goes together. Now, floorboards are often joined using the joint shown. Name it. Well, this is a tongue and groove joint. Okay, and I don't think we've come across that before. So look, we're just going to learn it now. Tongue and groove. Basically, this here is the groove, and this tongue fits into it, and it's usually used in flooring. Okay, and it usually makes the flooring a little bit more expensive, but it's a great way to put down flooring, because even in the event that your flooring contracts a little bit and ends up having gaps in between the flooring, there's still a little piece of timber in there that will stop. You'll still see timber if you look down through the gap. All right, next one is the claw hammer. Okay, so what's the claw hammer used for? Well, it's used kind of as a lever to pull nails. So you would use it to take nails out of timber. And basically that's what it's for, claw hammer. All right, and then the last one, number 20, was give one use for a computer in a materials technology wood workshop. Well, first of all, for CAD or for CNC work, so in other words, controlling a router. But you could also have it, and I suppose this is more in your interest, it's for designing projects as well and researching. Design and research for projects. Very handy, a very important thing, design and research for projects. You might also use it for managing stock. Managing stock levels, and that's all I can think of then for the moment. There's probably more. All right, so there we go. I will put a copy of that paper on Google Classroom. And for today's lesson, I just want you to go through your own one and add to it, and particularly with anything you got wrong. And I also want you to learn anything that was new there. All right. Thanks, lads.